Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. In this session, we will see how we can test bipolar drive, push-pull, half bridge, full bridge, when we are using two transistors, two MOSFETs, two IGBTs, any type of two switching devices to drive power transformer. How we can test the drive signal for both switching devices. This is a question from my viewer. He said that he is facing problem to test the drive signal, emitter, collector. The center point, that is emitter and collector, and it is output point. One drive is here, second drive is here. When we apply drive signal to any transistor, any IGBT, between low side we can say emitter and gate, source and gate, emitter and base, MOSFET, IGBT, transistor. So the input signal is provided between these 2 points. To understand the complete flow of the signals, we will use TL494 based power supply. It is using TL494 IC, pulse transformer driver transistors, and finally we have output MOSFETs here. These will drive this transformer. If you don't have good practical experience in electronics, in electrical circuits, never do this experiment, because we are testing live voltage and it needs very special care. First of all, we need to see which type of drive signal is coming out from that device. Either it is open collector or totem pole. If we are using SD3525, it has its output stage like this. When this IC will turn on its output, we will receive this pulse at channel A, channel B. But if we are using TL494, it have open collector outputs. If we will apply positive voltage here at collector, we will receive switched positive voltage in the output R. If we connect it to ground, so it will provide switched ground at the collector. We are taking output from emitter or collector. In this TL494, if pin number 9 and 10 are grounded at that time, these are emitters. We will take output from pin number 11 and 8. At that time, this IC will provide switched ground here, and here we have pull-up resistor 3.3K, 3.3K in both channels. Between pin number 11 and 12, 12 is VCC, 8 and 12. So both transistor bases are pulled up. When this IC will switch one transistor at that time, this transistor will turn on. Let's see it. We will follow these signals step by step. The second point of safety, that we are testing live electrical signal. Never touch any component here. Might be live voltage can appear in the chassis, in the oscilloscope. It is best option to use battery powered oscilloscope when we are testing live circuits. If you don't have battery powered oscilloscope, use isolation transformer and remove safety ground. That is not recommended, but when we are testing live signal, it is very important to remove safety ground. If you don't have isolation transformer, at least use 2-pin plug to power on this oscilloscope. Safety ground must be removed from oscilloscope when we are testing live voltage. Either it is not recommended, otherwise it will make a huge disaster. Here I have two MOSFETs. In the first step we need to trace the circuit, which is the lower terminal. Here we have negative, positive, negative, positive, and if we see this negative and this positive are connected together, so this negative is reaching to first MOSFET's source pin, and these positive voltage are reaching here at drain pin. When this MOSFET will switch, it will switch positive voltage to this point. When this MOSFET will turn on, at that time it will switch negative voltage, the ground potential, to the drain pin, so it will drive the power transformer. Similar here, this high side transistor, either it is transistor, MOSFET, IGBT, whatsoever, low rail is reaching to this emitter, source pin of the MOSFET, emitter of the transistor, emitter of the IGBT. Now when we will check this signal with respect to ground, we will receive positive voltage, these voltage at this 11 number pin through this resistor. So when this IC is off, we will receive high level voltage. When this will receive high level voltage, that means the IC is not switching. When it will turn on, at that time our this pin will reach at the ground potential. This circuit have two type of level of switching. One is the secondary side, that is isolated. So this IC TL494 is secondary side regulator. So we will use secondary ground, that is ground for this VCC capacitor that is here, that is applying power to this point. If you see, this is power transformer, and this end it is ground, it is reaching at pin number 9 and 10. And if you see these 2 points, these are rectifiers, these are providing positive voltage to power up this IC. So I will use this common point, this is reference point, to test the output signal of this IC. As I discussed that when we will receive high output at pin number 11 and 8, at that time we must understand that this IC is not switching. When the level is high, that time the output is open circuit, that this ground is not connected, and we will receive these positive voltage here through this resistor at this pin. I will connect channel A to pin number 8. Here is pin number 8. Here is pin number 8. Now we will not use the both grounds for channel A and channel B. We will use just only one ground, and we will remove this clip. That is best option. This is pin number 11. I connected the jumpers to save the time. Now we have two type of drives. Remember that when the power is applied, never touch metallic connectors of this oscilloscope, or never touch this circuit. So for that purpose I removed this grounding clip. Now we can see both signals are opposite to each other. In this period, when the signal is low, at that time this IC is turning on and it is providing ground output, as I discussed here. This is one transistor, we can say 8, and the same second transistor, (11). This is pin number 9, this is pin number 10. So both transistors are switching one by one here in push-pull condition to drive half bridge transformer. This is off time. When the signal is high, that is off time. When the signal is in low condition, that is on time. Because we are testing signal with reference to low point. So switch to low side will indicate that this is on time. We have another option. Just press channel 2 and use invert function from options. Channel 1 invert function. Now we are receiving inverted signal. Signal at this point is same, just we are inverting the display to understand the switching sequence. This time we have this on time, vs off time. So this time I will turn off the invert function. Now we tested signal between ground point and pin number 11 and pin number 8. So we are receiving this signal here, and at this point we are receiving both signals are opposite to each other. Now we will check signal at this point across this transformer. For that purpose, we need to check this signal at this reference point, because the current will flow from this center tape winding to this side and this side. Now we will shift the reference point, that is this positive point, that is the output of auxiliary winding, positive terminal of this capacitor, VCC capacitor. This is same, this point is reaching to center tape of this pulse transformer. Now we will connect oscilloscope across this transformer. These are points for this transformer. Oscilloscope test probes must be connected at 10x. Either you are using any type of oscilloscope, no problem. The function will remain same. This is the drive signal here at this point across this transformer. This is high drive and this is high drive. At one time the current will flow in this direction, the second time the current will flow in this direction. This is input side. Now we will see output side. The output side have slightly different configuration, and we need extra safety and extra care while testing this signal. Here we need to identify the low rail, that is this point. Now this is our reference point. Here our reference point was this point, center tape of the transformer winding. Here our reference point was here. This is reference point and this reference point for these signals. This reference point for these signals. But now our reference point will change here, and this time signal condition will change. Let me disconnect power. Always verify voltage at these capacitors before touching to the board. Use multimeter to verify the voltage. Before this we were working in secondary side. From this point to this side it is secondary side, and from this portion to upside this is primary side. This is capacitor negative terminal. It is reaching to this transistor's emitter. Either it is MOSFET at the MOSFET source pin. If it is IGBT emitter. These positive voltage are reaching to this collector. If it is MOSFET, then it will reach to drain. This gate or this base emitter. This gate or this base emitter or source pin. So we will select our reference point at this negative terminal. I will connect channel A to this emitter, that is this one, and now we will check voltage across emitter to base junction. So we will check voltage drop across this junction. Let's see it. And we will also monitor the voltage coming out from this collector, that is here, this point. Now this high side pulse, this one, this is signal drop across this base to emitter junction. This small pulse that is from zero line to upside, this small pulse that is going upside, this is turn on time for this transistor. When it is turning on, at that time this negative side voltage are switched and these are reaching to this transformer winding. That time the transformer voltage this end will drop to low side, that are these voltage. When this transistor is turning on, transformer voltage will go to low side. At that time coupling capacitor here will connect voltage at center line here. So this is turn on time for this transistor. This reverse peak, this one, it is turn on time for this transistor. This peak, it is turn on time for this side. At that time these positive voltage will reach here, because now our reference point for this transistor is floating. So that is the reason we are taking this wave shape here. Now let me disconnect power. Now if I will select reference point, this emitter to this base, now we can see this top side signal is now base to emitter drop voltage here. Now this is turn on time for this transistor, and this downside peak, that is reverse peak, that is turn on time for this transistor, because when forward voltage will reach at transistor base, at that time this transistor will switch. If it will receive negative voltage, why it will receive negative voltage? Because when one side will switch, this end will become positive, this end will become negative. When it will become negative, this diode will reverse bias. At that time this positive voltage will reach here and it will switch. So we will receive base to emitter voltage. At that time the second side is reverse biased. When upper side transistor will switch, it will provide positive voltage at this transformer. When this will switch, first transistor, at that time it will produce negative voltage, this negative line. So this negative line will switch at the transformer. Now let's see the transformer condition. This is the voltage swing from positive negative. Because it is half bridge, this is turning on time for one transistor and this is the second one. When positive voltage are at transformer, that time this top side transistor is switching. When this negative peak is there, at that time this low side transistor is switching. So in this way we can verify the switching function of both transistors. What is the safety point? Now, as we discussed, we have two transistors. This is output terminal, this is negative, this is positive. One drive here, one drive here. This is oscilloscope low side. And here we will connect high side. So it will take this pulse. Now when we are connecting the second probe, we will not connect this clip, grounding clip. Why? Because we need to measure the voltage from these two terminals. But now if we will connect this grounding probe here, what we will do, this is common at oscilloscope end. So these both ground points are connected at common point. So if we will connect both probes ground point here and here, what we will do, at that time we will provide an easiest path to this positive voltage to reach to the ground. So it will damage the probes, it can damage this transistor, or it can cause to personal injury. So we will not connect this probe. At that time, here we will receive 0.7 volt drop across this junction. This is forward voltage, that is upside voltage from the zero line. But when we need to test this signal, we will use this reference point and we will measure voltage between these 2 points, here to here, from this emitter to this base. What will happen at that time? Its base will keep floating up down, but we will consider this negative pulse, that is a reverse swing in the off time. When the second transistor is turning on, at that time our this transistor will receive negative peak, because second winding one end is going to positive side. This end will become positive, this end will become negative, because it have to provide 180 degree out of phase switching pulse. I hope you enjoyed this video. If it is good, hit the like button. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.